So here's a little person, and I've drawn their face, and you can see in blue at the bottom I've drawn their voice box. And I'm going to show you exactly what happens when you draw a little molecule like this of oxygen and follow it along its journey. So it's going to be breathed in either through the nose or through the mouth. And you know it's going to kind of end up in the same place, or so we think, right? We said that basically kind of the back of the throat is where it's going to end up. And this is my nose kind of going to the back of the throat, and the mouth kind of empties into the same spot. But already there are going to be some differences. So for example, you have in your nose these little yellow nose hairs. And the first question, of course, people think of with nose hairs is, what the heck is their purpose? What do they do? And nose hairs are part of our filter system. So we have this great filter system, and there's nose hair, and their job is to make sure that all of the kind of large particles of dirt and dust are kind of picked up. So they're good for getting all the large particles out of the air, so it's cleaned up. And then you also have this kind of green slime, right? This kind of green mucus that we all kind of make. And this mucus, sometimes you think of it as snot. This snot or mucus is good for small particles because it's really sticky. And the small particles of dust and dirt are going to glom onto it. And so that is our way of kind of cleaning up the air so that when we breathe in through our nose, the air is basically clean, or at least cleaner than it would be otherwise. And so, of course, if you compared nose air, or the air that you breathe in through your nose, to air that you breathe in through your mouth, the mouth air will be, of course, a little dirtier because they didn't have that nice filter system. And kind of thinking along the same route, if you think about picking your nose, that would be basically kind of cleaning the filter, right? So that's kind of a new way maybe of thinking about that habit. So air is going to end up going to the back of the throat. So air is going to kind of go in this way, and our little molecule of oxygen is going to kind of end up at the back of the throat. And another kind of interesting difference is that already that oxygen molecule and the air around it is going to be slightly different in other ways. It's going to be cleaner if it went through the nose, but either way, nose or mouth, it's going to be warmer and also more moist. So that's another change. In comparison, on the outside, the air is a little colder and drier. So these are some key differences in terms of what's happening to the air. These are two major differences, right? So now the air, or our little molecule of oxygen, has got a choice. It can either go kind of down one of two paths. One I'm going to draw is going to be into the larynx. This is our larynx right here. And we also call our larynx our voice box. So you might remember that was the name I had mentioned previously. Voice box, or larynx is kind of the more medical word, I guess. And sitting over the larynx is the epiglottis. The epiglottis. And the epiglottis is basically like a lid, kind of protecting the larynx from making sure that food and water don't go into it. Now there's another tube I just alluded to, and it's sitting right here. And this purple tube is our esophagus. So the esophagus is basically, it's fantastic for things like food and water. You want food and water to go down the esophagus because it's going to lead to the stomach. So you want food and water to go that way, but you don't want food and water to go into the larynx. And so you want to make sure that the epiglottis, that lid, is working really well. And if you're swallowing food and water, this epiglottis will literally just kind of close up and protect your larynx. But in this case, that's not happening, right? We're not actually food and water. We're a little molecule of oxygen. So let's follow that molecule a little bit further down. Let's see what happens to it. I'm going to drag up the canvas a little bit, just make a little bit of space. And I want to just stop it right there because I want to show you that the air molecule, or the oxygen molecule, has already kind of made an interesting crossroads. It's actually kind of broken an important boundary. And that's this boundary right here. And on the top of this boundary, I've included the larynx and, of course, all the other stuff we just talked about, the mouth and the nose. And this is considered our upper respiratory tract. So anything above this dashed line is our upper respiratory tract. And then, of course, you can then guess that anything below the line must then be our lower respiratory tract. So this is an important boundary because people will talk about the upper and lower tract, and I want to make sure you know what is on which side. So on the top of it is the larynx and everything above that. And below it is the trachea. Let me label that here. The trachea is right here, the windpipe, or the trachea, and everything below that, which of course mainly includes things like the lungs, but as we'll see, a few other structures that we're going to name. So I'm going to keep moving down, but now you know that important boundary exists. So now let me just make a little bit more space so you can see the entire lungs. You can see the molecule is going to go through the trachea, and actually I have my left lung incompletely drawn. Let me just finish it off right there. So we have our right and left lung, right? These are the two lungs. And our air is going to just kind of slowly pass down. Our molecule of oxygen is going to pass down, and it's going to go either into the right lung or the left lung. Now here I want to make sure I just take a quick pause and show you the naming structure. And the important word of the day is the bronchi, which alludes to one, or sorry, I screwed it up already. The bronchi, which alludes to more than one, sorry about that, and bronchus, which alludes to one. So bronchi means more than one, and bronchus means one. So just keep track of these letters, I and US, okay? So if we say that, for example, we are going into this area right here. Let me just choose a new color so it's really clear. This will be our main. If we go into this spot, let's say our air molecule or our oxygen molecule goes this way, then we would say it's in our left main, I'm just going to underline as I go, left main bronchus. That's what we would call that. And then if it went further, let's say it went down here, then instead of calling it main, I would call it the lobar. That's the word here. So I'd say it's my left lobar bronchus. And then if I wanted to go a little bit further, I could say, well, now this is my segmental. So these are the words that we use, and this final one would be then my left segmental bronchus. And of course, if you want to talk about two of them, let's say I want to talk about, both this guy and this guy, then I would say those are my right segmental bronchi, because now I have to use the top word because it's plural. So that's the naming structure. And another kind of important naming structure you'll sometimes see is primary bronchus, secondary bronchus, and segmental they call tertiary bronchus. So you'll see either one of those, but I'm going to stick to main, lobar, and segmental because I think it's a little bit easier and more intuitive to remember it that way. Now, there are a couple important, interesting things happening already. So right here, this notch, or this point right here, this is our carina. So at the carina, you have your break between the right and left main bronchus. And what I want to point out to you is that this is a little bit more vertical. This right-sided one is a little bit more vertical, and the left-sided one is a little bit more lateral. This is a little bit more flat or lateral. So it's kind of a cool thing to know, which is that if something was to slide down the throat, let's say a penny or a peanut or something was to slide down here, it's more likely to go down this way simply because of gravity. So gravity is going to push things towards the right main bronchus more than the left main bronchus, because the right main bronchus is a little bit more vertical. So that's kind of a fun fact that you now know. And we should actually, I guess I didn't do this already, but we should actually take a break and make sure we name some of these things. Remember, this is called our cardiac notch. And you remember that that's one clue to kind of telling apart the left and right lung. And the other clue we said was the lobe. So of course the right one has the upper lobe, the middle lobe, and the lower lobe. And the left lung only has the upper and lower. So that's an important clue. I just want to make sure we don't forget our little tricks that we've learned for telling apart the lungs. So I'm going to take a little pause there, and now I'm going to show you in a sped up version all of the different branch points. So for example, here we have just a couple branch points, right? 1, 2, and getting into the segmental bronchi would be the third branch point. But I'm going to speed things along and show you how many more branch points there actually are before we get to the final part of our lung where the gas exchange actually happens. So enjoy. going back to the very point where we left off, we start with kind of a bronchi, right? And we said that there is a naming structure for how to name the bronchi, but that's really just the first three branches. And then after the first three branches, all of the orange stuff, all of those branches going from branch point 4 all the way down to about branch point 20, those are the conducting bronchioles. So that's the name we give them. They're no longer bronchi, they're bronchioles. And so if you see that word, just keep that in mind, that we're a little bit further along in the lungs. And then after the conducting bronchioles, you get into a few more branch points, and we call them the respiratory bronchioles. And actually the final, I should mention this, the final conducting bronchiole, sometimes you'll see this called the terminal bronchiole. It's that kind of a bad name because terminal sounds like we're done, but actually we're just done with the conducting bronchioles, and we're still kind of going into the respiratory bronchioles. I guess if I'm only pointing to one, I should just probably make it singular. And then finally you get into the alveolar ducts and the alveolar sac, which is kind of a few alveoli put together. And if it's plural is alveoli, then singular, just talking about one little part of that sac, would be alveolus. So that's where our little molecule of oxygen ends up. And this is kind of where it ends up before it's going to participate in gas exchange. Now, this entire area going from respiratory bronchioles on downwards, this is all called the respiratory zone. The respiratory zone. And anything above that is considered the conducting zone. So anything above that, and that really includes not just the conducting bronchioles, but conducting bronchioles, and then all the stuff above it. So all the bronchi, and even the larynx, and the mouth, and the throat, that's all considered part of the conducting zone. So basically, oxygen is going to come in through the entire conducting zone, everything we just talked about, and is going to go down into the respiratory zone. And finally, our little molecule of oxygen is going to be very happy to have finally made it to the very end of the bronchial tree and is ready for gas exchange now.